Hi everyone, this is Ashish. Welcome to my channel. Today we are looking at another Leetcode problem, that is best time to buy and sell stock, which is problem number 121 Leetcode. In this video, first we will be reading this problem and try to understand the problem with few examples, and then after that we'll try to cover a few clarifying questions that we should ask to the interviewer uh, when this question is asked during the interview. And in the last, we'll look at the solutions to the problem and try to submit the solutions in the Leetcode for verification purposes. And now let's dive into the question. So this problem has been categorized as an easy problem and has more likes than dislikes, which is generally a good idea uh, to prepare for your interview. And also it has been asked in recent interviews in the companies like Amazon, Google, Microsoft, Facebook, Apple, TCS, etc., which is one more reason to study this problem thoroughly. In this problem, you are given an array of prices where price I is the price of a given stock on the ith day, and you want to maximize your profit by choosing a single day to buy one stock, and you have to choose another different day in the future to sell that stock. And from this transaction, you have to maximize the profit that you can achieve. And if you're not able to achieve any profit, then you have to return the value of zero. And so basically, for all the finance people, we cannot short the stock. And for the constraints, it has been provided that the length of the price array will be from 1 to 10 to the power 5. That means that we don't have to put a check for whether the prices value is null or it has a empty list. And the prices elements in that prices array will be varying from 0 to 10 to the power 4. uh, Again, for the finance people, I know that 0 cannot be achieved as a price, but for this problem's sake, it doesn't make much difference mathematically, so we can assume this constraint as well. Now let's look at the few examples. First two examples that have been given in the Leetcode itself, and the third example that I have prepared by myself. And in the first example, we have been given an array of 7, 1, 5, 3, 6, 4. And if you look at it, if you buy the stock at price 1 and they sell it at 6, this is the maximum profit that we can achieve, and that is $5. That is the solution. And again, in the second example, we have been given an array that is decreasing. So any price is lower than the prices that has been coming earlier in the array. So that means we cannot achieve any profit, and that's why the solution will be 0. And the third example is an interesting one because we have the array of 146 and 156. So if you buy at 1, then sell it at 6, then again buy at 1 and then sell it at 6, we'll be making a profit of $10. But for this problem, because we have to execute only one transaction, in that case, we have to give the answer of 5. So let's look at the few clarifying questions. Uh, First question is that you can ask that if the prices can be float, because we might face issues in comparison later if prices become float, and we do have to make sure we are comparing until the certain decimal places. And the second question can be, is there a possibility of multiple solution? If yes, then how to handle them? For example, in the previous third example, if because we have like multiple solution, in that case, do we have to give an answer of value 5 or we have to give an answer of 10? For this problem, we have to give answer 5, and if the answer becomes 10 from the interviewer perspective, then you have to think about any other uh, statement. We have to modify the solution a little bit. Okay, let's look at the solutions now. In this solution, which is a nice solution, and that we can come up very quickly out of our mind. So in this one, we'll be looking at the First we have to we have to initialize a variable that is called maximum profit, and which you have to initialize the value as 0. And in the step 2 we'll be iterating the element from 0 until the second to the last element. We can run it until the last element also, but the last iteration will not result any value. And in the second loop that will be going under this loop is the future values from the current element of the first loop, and that will go from the next element, uh, which is the current next element to the current element of the first loop, and goes until to the end of the array. So basically, in the step 2 we are trying to figure out the buy price, and in step 3 we are trying to find out the sell price. And under both the update the max profit, otherwise we'll keep the same value of max profit that has been calculated until now. For example, in the first iteration here, the first loop will be at 7, and the second loop will start at 1, and the second loop will be finding the sell price at 1, and the buy price is 7. So the profit, which is actually a loss of $6, will be attained. And if we compare it with the maximum profit that was already assigned as value 0, then we'll be getting the value of 0, which is minus 6 is less than the 0. So 0 is the maximum value that you can get here. So the maximum profit stays unchanged. And looking at the space and time complexity, because we are not using any variables that is dependent on the size of the array. For example, we are using only max profit, which is a one variable, does not depend on the array size. Iterators for uh, the first loop and the second loop is also are not dependent on the array size, and the another variable called profit, which is also not dependent on the length of the array. That's why the space complexity is O1, and the time complexity is O(n) square, because of there are two loops involved, and that's the reason the time complexity become O(n) square in this case. If we look at the efficient solution for this problem, it is also referred to as cadence algorithm, which I'll be covering in the later videos in more details. But for this problem, we can think of instead of creating two loops for buying and the selling price, we have replaced that first loop of buying price to another variable called minimum price, which will be assigned initially to the first element of the array. And there'll be a loop that will be starting from the second element and goes until the end of the element arrays, uh, and which will be trying to find the sell price. And there is a this condition in the step 3 which makes the sentence that you have to buy at one date and sell at the second date, which makes that value as that sentence as a significant in here, because at any element in the array will be either updating the minimum price or will be updating the maximum profit. So if the current price that is in the iteration is below the minimum price, at that time the minimum price will get updated, not the maximum profit at this time, because we cannot update the maximum profit on the same date. And if we already have the minimum price, and if condition doesn't go into that first step, then you have to look for the maximum profit, and which will be the maximum of maximum profit as well as the current price minus the minimum price. And if you look at the whole iteration that I have created here in this table, is that first element is both min price and the maximum profit is NA, because the loop is not going through both of them at that moment, because the loop starts from the second element. And but the minimum price will be assigned as the price 0, which is 7. As soon as we reach the current price equals to 1, the minimum price will be assigned to be value 1. At that time, maximum profit will not get updated. Maximum profit will get updated after that on the current price 5, which is updates the value of 0 to 4. and and when the current price reaches the value 6, the price is increased from 4 to 5, because that is the maximum profit, but the minimum price stays the same throughout the period, because that is the minimum value that you can find in the array. So if you look at the space complexity, again we haven't used any variable that is dependent on the length of the array. So the space complexity stays the value of O1, and the time complexity becomes On because there is only one loop that is involved, that is in the step 2. That's why the space complexity becomes On. Now let's try to implement these solutions into the Leetcode. And here, as you can see, this is the problem statement that we have, and these are the examples that I have covered, and these are the constraints. And if we try to implement the solution, first what we will do is we'll create the length of the prices variable, uh, which will be the length prices, and then we'll maximize the profit equals to 0, which is another variable. And then in the first solution, what we'll do is we'll run one loop where iterator I is in range from 0 until the length of prices minus 1, and there'll be another nested loop in there which will be looking for prices from I plus 1 until the L of prices. So this is looking for the buy price, and this is looking for the sell price. And if price is J, and then after that we'll be creating a variable called profit, which will be prices J minus prices I, and if profit is greater than max profit, then we'll update the max profit equals to profit. Otherwise, and after all the iteration, this will return the value of max profit, and which will be the solution. If we run this solution now, it's getting accepted. But if we look at if we try to submit this solution to the Leetcode, it will not accept this solution because the time limit will exceed because of these two loops. As you can see, the time limit has exceeded because of this, because of Python is a little slower programming language, and the loops are creating issues here. So if we look at the our efficient solution, so I have taken a backup of the original solution, and in the efficient solution we just have to create one more variable that will be prices of 0, which is the first element, and then we'll be removing that by price uh, loop, and we'll be just considering the loop for the sell price, and which will be going from the first element until the last element, and we'll be and then after that we have to put if condition that we were waiting for, is if uh, prices I is less than, actually the price is J here, if it is less than the minimum price, then we'll just update the minimum price. If that is not the case, then we'll get the max profit updation by max of max profit and price is I, actually j minus min price, and whatever this value results, this will be only one loop, and it should get accepted now. So as you can see, all these examples that has been given, they are getting accepted. If we submit this problem, uh, then this problem gets accepted, and so this is our efficient solution, and it is also getting accepted in the Leetcode. So that's all for today. Thanks for watching, and please like, share, subscribe, and comment any feedback if you want to give. Thank you.